Hello and welcome back. In this video, we're going to find a formula for the inverse function for the hyperbolic cosine. And to do that, we're going to first let y equal the hyperbolic cosine of x. And if you think back to the process for finding an inverse function, we always exchange the variables x and y, and then we solve carefully for the variable y. So in doing our swap, we're going to have x is equal to the hyperbolic cosine of y. And now's a good time to pull up the definition of the hyperbolic cosine function, which is e to the variable, which will be y, plus e to the variable with a negative divided by 2. And now we need to go through and isolate the y. So first step in doing so is to multiply both sides by 2. And we're also going to change the order around so that we have the y variables on the left-hand side. So that gives us e to the y plus e to the negative y equals 2x. Next thing for us to do is to multiply through by an e to the positive y. So we're going to have an e to the y on both sides. So we're going to have e to the y times the original e to the y plus e to the negative y over here. And on that side, of course, we'll just have an e to the y times the original 2x. Multiplying this through, we're going to have an e to the y plus y, which is e to the 2y. And then multiplying the e to the y times the e to the negative y gives us a 1. And on the right-hand side, we've got 2x e to the y. We now will bring everything over to the left-hand side. And in doing so, we're going to have an e to the 2y plus a negative 2x e to the y plus 1 equals 0. Or more importantly, an e to the y quantity squared plus a negative 2x e to the y plus 1 equals 0. You will notice that this is actually the quadratic formula in terms of e to the y, because it's a variable squared plus a coefficient times a variable, the same one, plus some constant equals 0. So using the quadratic formula, we've got e to the y equaling negative b, so it's going to be the opposite of the middle term. So that's 2x plus or minus the square root of the middle coefficient squared, your b squared, minus 4 times the leading coefficient, which is 1, times the last coefficient, which is 1, all over 2 times the leading coefficient, which is just 1 again. So we've got an e to the y equaling 2x plus or minus. And inside the parentheses, we have a 4x squared minus 4, and this is all over a 2. We can now simplify this down by taking a 4 out of each of those terms. So that's going to be the square root of 4 times x squared minus 1, all still divided by 2. And then you'll see that this is going to be 2x plus or minus the square root with a 2 in front of it, which I just forgot. So let's put that back in there. 2 square root x squared minus 1 all over 2. And we can now cancel out the 2's by dividing everything by 2. And we have e to the y equals x plus or minus the square root of x squared minus 1. And our 2 is gone from the denominator. So at this point in the process, you're thinking to yourself, well, there's a plus or minus here in our answer, but there's no plus or minus back in our original formula. And recall that e to the y must be a positive number. So therefore, we want to make sure that we are not subtracting too much away from the x, because that will make it a negative quantity, because that second term is always going to be growing as x gets larger, and it's going to be a little bit smaller, so we don't want to, actually a little bit larger. So we're going to have an e to the y equaling x plus the square root of x squared minus 1. And again, we want to have a positive quantity here. So next thing to do, of course, is take the natural log of both sides. So we've got the natural log of e to the y equaling the natural log of x plus the square root of x squared minus 1. Because they are inverses, we can cancel out the natural log and the exponential. And we have our inverse y equaling the natural log of the quantity x plus the square root of x squared minus 1. And that y we know is the hyperbolic cosine inverse of x. And this formula will only be defined when x's are greater than or equal to 1. Because we can't take the natural log of negative numbers. So therefore, if we go back, we have shown through direct computation of the inverse function that the hyperbolic cosine is just the natural log, hyperbolic cosine inverse of x is the natural log of x plus the square root of x squared minus 1, which is exactly what we wanted to show. And similar computations can be used to verify the hyperbolic sinh function, hyperbolic tangent, and so on.